Good evening, and let's start the class. So now in the today's lesson, what we have to discuss is one more sensor, that is the ultrasonic sensor. So that we need to discuss. So we have to start with, actually we have started the lesson with the sensors and the different microcontrollers. So out of that, we just discuss about the first microcontroller that we have discussed about microbit. But microbit is a bit, it's very easy because some sensors are integrated with microbit. So you don't want to attach sensors separately. No need to create the circuit separately. Most of the sensors are integrated to that. So that is why the microbit codes are very easy and easy to implement. But when it comes to the Raspberry Pi and this Arduino, so there are differences. Arduino actually, it's a open source, free and open source one where you can connect the sensors separately. And so importance of Raspberry Pi is it's even coming with operating system called Raspbian. So let me show. Raspbian is the operating system used in Raspberry Pi OS, Raspberry Pi microcontroller. Actually, when you get Raspberry, you will get that with the operating system. You can install that to a micro SD card and put it into the Raspberry Pi microcontroller. That is really convenient because you can do a lot of activities with the operating system. And not just that, you can do the coding. And here you can see Scratch coding is there, Python is there. So Java is there, so Office applications are there. So all these are integrated. It looks like a small computer and laptop. So it's a mobile computer, right? So, but other things are also computers, but you cannot feel that because no operating system is there. Here in Raspberry, you have operating system too. So that is the difference. And let's move to the next part, which is now we have discussed about Arduino. Last day we just discussed about PIR sensor, how to use PIR sensor in Arduino, passive infrared sensor. Actually, Arduino, there are different versions of boards. So that Arduino Uno board is the one that we are going to use now for the coding. But in other than that, you have Arduino Mega board, so which is used for large projects, and there is another one. So that is Arduino Nano and Arduino Micro. These are small, which can be used for small, relatively small projects. But so Uno is easy, Uno is easy to use. It's convenient because the pins are available for direct connection. You can test this and all. But still, so other than using Uno and Uno, because thinking about the cost and also the mobility and portability, for small projects, you can use Nano and Micro too. So please consider that as well when creating small projects. So this Nano and Micro is more suitable because when considering about the cost and the portability, because it is small, it's very small. Therefore, these are very good solutions too. And then we learn about this breadboard connection, how it happens, the horizontal connections in the plus minus pins and the vertical connections in the middle pins. We just discussed about that too. And last day discussion was about the passive infrared sensor, which is human motion sensor or motion detection sensor. And today's topic, let's discuss about ultrasonic sensor. So which ultrasonic signals are actually beyond our hearable limit. So what is the human hearable range? So
20,000 hertz.
Yeah, it's 20,000 hertz. 20,000 hertz. So that is the human hearable, human audible limit. So 20,000 hertz. Right? So to test that, you can use this link. I would like to give this tone generator of this one. You can also test this, self-test your hearable limit. So unfortunately or fortunately, I cannot hear large frequencies. I don't know why, but I can hear only up to 15, 16,000. So check whether you can also hear same. So let me play. I cannot hear which is below 20 anyway. So this is because I am human. So I can hear beyond 20 hertz. But again, when it comes to very high frequencies, I cannot hear. So 17,000, 18,000 frequencies, I will not be able to hear. Maybe with the earphone, I'll be able to. But without earphones, I can only hear around 15,000, 16,000. That is the maximum. Let's play this and see. You can also play this and see here. Just play this using small play button. See how it plays. Still I can hear, it's audible. These are 6,000s, 7,000s, still I can hear. But little bit annoying because of the high frequencies, it's like annoying sound, but still can hear. It looks like mosquito now, it's like 10,000, 11,000, still can hear. Still possible. Still possible. Still possible. Okay, now I cannot hear actually. So can you hear? So check.
I can hear up to 18,000.
Oh, good. If you can hear up to 18,000. So my ear is stopping like 16,000. That range. After that, I'll not be able to hear. I cannot hear. So you can hear sounds 18,000. Good. Your ear range is high. You can hear high frequencies. Maybe my ear already got damaged, something right? I don't know. So can you hear like 19,000? So I don't think. Even the 20,000 is the hearable range. So when it goes closer to 19,000, it's very difficult to hear, right? Okay, you can just self-test and see, right?
Sir, I could hear up to 18,000.
18,000, okay. Maybe since I'm having a lot of background noises, like air conditioner is running, it has noise. Maybe without the noise, I'll be able to hear. I'm not sure, but so when it go beyond 16,000, 17,000, it's quite difficult. Like cannot feel much. It's not even much sound. Okay. Anyway, so now you can see this is human audible limit, hearable limit. But this ultrasound is beyond that. Ultrasound you cannot hear. But if you are a bat, or if you are a dog or cat, maybe you can hear some high frequency sounds because these animals can hear other frequencies that we cannot hear. Dogs can hear low frequencies and high frequencies. And some animals can hear high frequencies. Some can hear very low frequencies even. That's why like, so especially these creepers, so they can hear very low frequencies as they are really sensitive to the earth surface. And some birds can hear some high and low frequencies. And here this ultrasonic sounds, actually bats, they can feel the ultrasonic. They can emit ultrasonic and they rely on the reflection of the ultrasonic to detect objects and the obstacles, right? Therefore, we use this ultrasonic as obstacle avoiding sensor. So to avoid the obstacles and to detect obstacles, we are using the ultrasonic sensor. So here, this is what bats are doing. They emit ultrasonic signal or ultrasonic wave, and it go and hit on some surface, and then the reflection comes back. That is echo. Echo comes back. Actually, they listen to the echo and detect whether there is an obstacle or not. By listening to the echo only, they understand whether there's obstacle or not. This is very fast process. It's a very fast process, right? The obstacle, if obstacle is there, frequently, or this wave is traveling like the sound wave. So what is the speed of sound wave? Normal speed of sound wave? That is 340 meters per second, right? So that is 340 meters per second. That is typical speed of a sound wave. So it can travel 340 meters per second. It can go 340 meters. So far away, it's very right. Okay. So that is anyway. So with that speed, so let's see how this ultrasonic works. It also has a trigger pin like this bat. It can trigger or it can send ultrasonic signal. And the echo pin, it can receive the echo back to the echo pin. This is actually output, trigger, echo is the input. Trigger is the output and echo is input. GND is giving earth wire or the neutral wire to this, and VCC is giving power to this. So GND and VCC together provide the power. And trigger issues the signal, echo receives that back. So that is what happening there. Okay, so let's analyze this and let's see the calculation. Before that, let's see the calculation. Please write down today's topic, that is ultrasonic sensor. Under that, please write down. Under that, please write down. Bats can hear high frequencies or high frequency signals, sound waves, which we cannot hear. Therefore, they are sensitive to ultrasonic waves. They are sensitive to ultrasonic waves, which is beyond 20,000 hertz and can even reach 70,000 hertz. It uses the reflected or echoed or echo wave to detect obstacles. That is done by measuring the echo time. It is done by measuring the echo time. Speed of sound wave. So we measure that as 340 meters per second. So you can write that as actually, which is equal to 34,000 centimeters, because 100 centimeters is 1 meter. So you multiply by 100, so you'll get 34,000 centimeters per second. So which is equal to 34 centimeters per millisecond. So millisecond is millisecond, 1 millisecond is equal to 1 divided by 1,000 seconds, right? So you divide it by 1,000. So you divide it by 1,000. For millisecond, it travels 34 centimeters. So again, you can tell So with that comparison, you can say it is 0.034 centimeters per 1 microsecond, or per microsecond. Actually, 1 microsecond is equal to 1 divided by 1000 milliseconds. Okay, so then so there is an equation, the speed or velocity. So you can say speed or the velocity is equal to distance divided by time. Distance, so divide by time. So that is the equation, right? So if we consider an object which is 20 meters away, so 20 centimeters away, from the sensor. So actually you can apply this. You know the speed is 0. This is the speed, centimeters per second. So that is equals to distance is like 20 centimeters, and so this is actually you have to divide that by microsecond. That is the actually distance. The time we don't know, but at time, let's say t. So this t can be taken this side, and then you can write t equal to, so this t can be taken the other side, and you can say t equal to 20 centimeters, that you have to divide that by 0.34 centimeters per second, and that you can cut centimeters and this centimeters, and the value will be, t will be equal to 588.2, and the answer will come from the microsecond. So if it is away like 20 centimeters away, it will take 588.2 microseconds to reach. If the object is 20 centimeters away, so it will take 588.2 microseconds to reach that object. And the reflection comes, to reach and reflect back, it will take so closer to 1 millisecond, right? To go and come back. So this is to reach, no, this is to reach the object, to come back another 588.2 microseconds. So it will be like, total is together the total will be around 1 millisecond. So please write down these facts. This is how the calculation happens. Okay, now let's do it, right? Since you have done this, let's trade the circuit. Okay, you can use Tinkercad to do this. I'll send you the link. So this is Tinkercad. So I already asked you to create the account. So you can use the same account which you have created. If not, please create an account. And if you don't know how to create an account, still you can ask. So that is what the punctuality is. If you know how to become a punctual and sensitive person. So then what you need to do, sensitive and sensible person, you need to indicate your problem, especially in the online environment. You all need to be polite. You have to tell your real story. Don't pretend. Right? If you're pretending like you have done, or if you're pretending like a zombie, if you're pretending like you are not there, you are physically, your body is there, but your mind is out. Right? So if you're pretending like a toy, so then you are not good to learn in this online environment. In online environment, we need real students. Actually, that is why I like the physical online classes rather than the physical classes. Most of the teachers, students prefer physical classes, but I prefer online class because if you are honest only, you can complete the activities in the online class. You have to be honest because here teacher cannot see you. You cannot see the teacher. You can do anything with your computer. You can play around. You can watch TV. You can move away. After logging to this, you can keep it there and move somewhere else. You can do some activities. You can chat with your friends. You can watch videos. You can do anything that you like. You have complete freedom to do anything that you like. But only if you are worrying about yourself, only if you love yourself, only if you consider about yourself, you are in the class. So if you really love yourself, if you really respect yourself, not me, if you really respect yourself, you can be honest. So be honest. So that is one of the great features or great attitudes that you can train in online class. When you become honest, you will start learning, right? So be honest to yourself. So let's start creating the circuit now. So let's go to the circuits and then start creating. So what I'm going to do is I'm going to take Arduino UNO board. I have to browse here, Arduino UNO. So this R3 board I'm going to take. Then I'm going to take ultrasonic sensor, ultrasonic distance sensor, this one. So I'll take this one. That is with 4 pins. There's a one with 3 pins also here. So just take the 4 pin HCSR041, right? So that is the blue color one. HCSR04, the blue color one. Please take that. And let's do the connection. Let's connect this. First, you need to ground this pin, GND. You have to ground that. And I'm using the GND pin here to ground it. Grounded. Then VCC, I have to provide 5 voltage. I'm using this VCC 5 voltage pin to connect that. Now the power is given. The trigger pin, I'm going to connect that to pin number 9. The echo pin, I'm going to connect that to pin number 8. Okay, this is my diagram. So you can also create the same, or you can change the ports. That doesn't matter anyway. You should give power to this. The VCC need to be connected to the 5 voltage. GND need to be connected to the GND. And then these 2 pins you can connect to anywhere that you like, but should be digital pin. Okay, I hope you are doing with me. Let's start the coding. And in the coding, please select text mode, right? When you click the code, so block mode comes first, but just select the text mode. They will ask question, do you really need? Yes, continue. First of all, you have to define your trigger pin and echo pin. So you can say hash define trigger pin. Trigger pin is connected to 9. Then again define echo pin, that is 8, right? Echo pin is 8. You have to define that. And further to that, you need to measure the duration, say duration. The data type is long. Long means you can measure large duration with the long. You can measure very large figures because you are going to measure it with milliseconds, microseconds. Better to have large figures. And int distance too. You need to measure the distance. These are the variables that you're going to. Then in the pin mode definition, you have to define the trigger pin. Trigger pin is the output, yes. And then echo pin is the input, right? Echo pin is input. Okay, let's do this part first. I'll give you time. Please do this part first. I'll give you 3 minutes to complete this part. Right, then now the first part is done. So now actually you have to start triggering the trigger pin. So that can be done this way. You can send a low signal from the trigger pin. And let's delay microseconds. And I'm going to delay 2 microseconds, very small time. And then I'm going to set this to high again. And this time I'm going to wait 10 microseconds and back to low. Actually, what I'm doing here, I'm sending. So I'm making it low, then sending high. Actually, I'm sending a small signal and then I'm again lowering that. This is sending a small microwave, small ultrasonic ultrasonic wave, small ultrasonic wave. So that is what I'm doing here. Small wave is sent. Actually, so you have to do something here that, so let's use the serial monitor. So I couldn't tell that serial.begin, and you can just with 9600 baud rate, you can begin this, and then you can serial.print ln, let's say, you can say ultrasonic sensor experiment, ultrasonic sensor experiment, and let's run this one more time and just want to show that if no errors. So just click on the serial monitor here, which is underneath, and you can see ultrasonic sensor experiment. That text comes here. The serial monitor is just used to give some output, a text output. That is why it's here. Right? That is why I'm beginning the serial monitor and showing some output there. Actually, what I'm going to do is I'm going to capture the signal back, the pulse in or the signal back. So then, so actually this can be captured to the duration one. Right? Duration one, I can just capture the pulse in which is going through the echo pin, that I can capture and then use the same serial monitor. So in case this pulse in is high, means if you're detecting some high signal there, then this can be used to like if there is a high signal in the pulse in high signal, so that can be used to identify an obstacle. So I'll use that part first, but please add the serial monitor. So that is, and also generate the signal and also add the serial monitor, please. The other part I'll explain next. So please, let's do one by one, right? So do up to this level now, please. I couldn't write there high, right? You have to detect high voltage from the pulse in, right? From the echo pin, you have to detect high. Okay, I think you are done with this also, and I'll anyway give the time. So now the calculation that we have learned here. So the calculation related to the ultrasonic sensor says, so you know the equation, speed equal distance, right? Speed is equal to distance divided by time. Then you can find the distance. So how you can find the distance? Distance equal to speed multiplied by the time. So speed, you know, 0.034. This 0.034 centimeters per millisecond. So centimeters per microsecond. So yeah, just using microseconds. Centimeters per microseconds. So that is your speed. And then the time need to be there. The duration is calculated here. That duration you can use. And this you need to divide by 2. The reason is, so this is two-way, right? The distance is calculated two-way. Why? In order to trigger pin to issue the signal and echo pin to capture. That means you have to, like, first it has to move the signal and then come back. So this is the duration. Actually, duration is measured both ways. Then you have to divide it by 2 to find out the actual distance. The duration කියන්නේ මෙතනට කියලා මෙතනටත් එන්න වෙලාව. ඒතකොට distance එක බලන්න නම් මේක දෙකෙන් බෙදා ගන්න. Otherwise it will calculate 2 times of that. So let's print that finally. You can use the serial monitor to print that. This part is not needed. The serial monitor, you can use the print signal and then you can say distance is then you can add another point, serial.print. You can print the distance that you have measured here. And this is measured in centimeters, please remember. So you have to write that in centimeters, that you can add the print cm, right? Distance is distance cm. So let's run this. Go to the serial monitor to see that, and you can see ultrasonic sense experiments, nothing comes there. Here. Okay, you have to do something that is print ln. We have to go to the next line, otherwise this is not clear. Okay, let's click that and right. You have to click on the ultrasonic sensor. Click on the ultrasonic sensor, then only the obstacle appears. Then move this obstacle here and there and see. So this shows the actual distance from here to here. The measured distance is 183.84. That is the measured distance. It is little more than the actual, little less than the actual. Don't worry about that, because this calculate with the reflection time, the direct distance, all these things will be considered. Because even the object is here, distance from here to here, here to here, 2 distances. So it's taking the somewhere average, right? Somewhere here. So don't worry about the actual distance mentioned here. When you click on this ultrasonic sensor and change the distance of this object, you can see it's mentioned here. It's mentioned here. Okay, let's minimize the serial monitor. And can you please add this code segment? This is the calculation that we have learned. Please add this code segment there and see how it behaves. Now it's your time to update. Okay, so in case if you have any doubts, any errors, any questions, now you can ask. So this is the code, this is the final code that we have come up with, and this is the circuit diagram. And if you have any doubts up to here, now you can tell me, then I can ask you to share the screen and help. So be honest, right? So I always say, be honest. If you have not done, tell me, then I can help you to do from the beginning. Doesn't matter, because this is your class, right? Okay, no such request means I hope everybody has done that. If not, again, you have 2 minutes of time, tell me, right? Okay, this is what we have come up with, and with that sensor, your syllabus related to the particular part ends. We have discussed about the sensors, and the next will be the computer networks. I have planned to start that topic next week, and so please be informed that you have your term test, second term test scheduled, and you will be getting questions up to chapter number 4 and some from the beginning of chapter number 5 networking session, because next 2 weeks will be added, and this will be the second term test. So that is there in second week of August, second or third week of the August. Just see, I think the schedule has already sent. So test will be there through Edmodo. Please make your account. If you have not created the accounts, do it. So that is compulsory. And next week I'll be discussing the networking lesson. And before that, I'll be going through the workbook as well. And so workbook, I think we have very few activities. Most of the activities we have already done. And the final topic is ICT and society. So these 2 topics I'll be covering. So next week I'll be starting the chapter number 5 networking lesson. Then good night. See you all next week.